electrons really move?
Right. And you've probably heard this idea, maybe you even thought it yourself, that electrons in a wire just zip along at the speed of light.
Exactly. It's a really, really common thought. But it turns out that's mostly a misconception.
Yeah, and the sources we're looking at today really help clear this up. They show that electron speed is, well, it's incredibly varied. It really depends on where the electron is, what it's doing.
Okay, so that's our mission for this deep dive. We're going to unpack these sources, cut through some of that confusion, and show you the surprising range of speeds. We're talking like shockingly slow sometimes.
And other times, mind-bogglingly fast. And we'll explore what happens when they get pushed right up against that ultimate speed limit.
We're aiming to give you the real picture, the nuanced one, based on the info you shared with us.
Okay, so where should we start? That big misconception, wires.
Yeah, let's hit that one first. Electrons and wires, speed of light. You flip a switch, the light comes on instantly, so you think, must be fast, right? Light speed fast.
Makes intuitive sense. But the sources, they paint a very, very different picture for the average speed along the wire.
What do they say? How fast is it really?
It's called drift velocity. That's the technical term for the average speed in the direction of the current. And it is incredibly slow.
How slow are we talking?
Like millimeters per second.
Wait, millimeters per second? That's practically crawling. Fractions of an inch per second.
Yeah. It's genuinely surprising when you first hear it.
Okay, then how? How does the light come on instantly if the electrons are moving that slowly? That doesn't add up.
Ah, see, that's the key insight our sources give us. It's not the electrons that travel instantly down the wire. It's the signal, the electromagnetic field.
The field.
Yeah, the wave that tells the electrons to start moving. That propagates down the wire at very close to the speed of light.
Okay, so it's like nudging the first domino in a long line.
Exactly like that. The fall signal travels down the line super fast, even though each domino only moves a tiny distance.
Got it. So the signal, the push, is fast, but the actual drift of any single electron down the wire is glacial.
Pretty much. Don't confuse the message carrier of the field with the things being carried along the electron's net movement.
Okay. But is that drift the only speed involved? Are the electrons just sitting there waiting for the push?
Oh, definitely not. And this is where it gets even weirder, maybe. While that drift velocity is tiny, the individual electrons inside the wire, they're actually zipping around like crazy.
Zipping around?
Randomly. Bouncing off the atoms in the metal, bouncing off each other. This random motion is related to temperature, quantum stuff like Fermi velocity. And those speeds can be really fast.
How fast?
Like a significant fraction of the speed of light, potentially. Really, really fast. But in all directions, canceling out.